Hello friends! Those of you who've seen the 1969 film Easy Rider by Dennis Hopper and Peter Fonda, also starring Jack Nicholson, can better understand the intro you just saw. Koba of Kero's Mac Mods was inspired by that film when he created two very useful accessories for BlueSCSI owners, which K named SCSI Rider. Now, for those of you who don't already know, BlueSCSI is a solid-state drive solution that replaces your spinning platter hard drive and uses an SD card for storage. Now, these two units are BlueSCSI version 1. This is an internal unit, and this is a DB25 external unit. But I also have the all-new for 2023 BlueSCSI version 2. Now, there are other competing products such as Mac SD, which is a great product. There's also SCSI to SD, Zulu SCSI, RAS-SCSI, and others. But these other products are shaped a little bit differently than BlueSCSI, and they also have their connectors in a bit different position. So the SCSI Rider kits that I'm going to build for you today are only compatible with BlueSCSI version 1 and BlueSCSI version 2. As shown on Koba's web store, SCSI Rider version 1 is a riser card that lets you easily mount and remove a BlueSCSI version 1 inside vintage Macs like the SE, SE30, Classic, and Classic 2. It may also work in a Mac IIcx or IIci, but that hasn't been confirmed. The benefit of a riser card is you can now plug in your BlueSCSI directly into the motherboard's internal SCSI connector. No need for 3D printed BlueSCSI mounting brackets, and you can remove the entire hard drive bracket too, which makes it easier to remove the main power cable to the motherboard. SCSI Rider also allows you to easily add a BlueSCSI to a Macintosh SE with two internal floppy drives, and it makes life easier for Macintosh Classic and Classic 2 owners when you remove the spinning hard drive and drive bracket. Going back to K's web store, we see that there's a SCSI Rider version 2 kit that's an external DB25 adapter intended for BlueSCSI version 2. Because the PCB of the new BlueSCSI version 2 is larger than BlueSCSI version 1, it's not possible at the moment to make an internally mounted riser card for it. That's why SCSI Rider 2 is an external adapter. There's an external DB25 version of BlueSCSI version 2 which sticks straight out the back, but it's 67% longer than the DB25 BlueSCSI version 1, which sticks out a bit too much for my liking. SCSI Rider 2 fixes that by pointing your BlueSCSI version 2 straight up, parallel with the back of your vintage Mac, similar to how the Mass Microsystems Hitchhiker drive attached way back in 1992. The only downside is that it isn't protected by a plastic case like the Hitchhiker drive. Both SCSI Rider kits are open source on K's GitHub page, which means you can make your own PCBs if you like. But if you only want one or two, it's cheaper and faster to just buy the kits from K's store. Both kits include the PCBs, of course, and all of the small components, but neither kit includes the required connectors. The good news is that on K's web store pages, you can find links to where the connectors are found on DigiKey. Now, because I've sourced the connectors that I need for my build, let's get started. Now I'm going to get started with SCSI Rider 1, and that's already here in my vise. Now you could use something like these if you want to go on the cheap, a pair of helping hands, but I found from doing the Koba 4 MB RAM build, if you haven't seen my video on that, please be sure to see it, that this vise with these nice rubber grips really works great, especially for SMD work. So if you have a vise with rubber grips on it, I would recommend that. What you're seeing here are all the recommended tools and the parts. In terms of parts with the kit, you get the PCB and you get a resistor, an LED, and the resettable PTC fuse. The two connectors, that's a matching pair set, you have to buy separately. Of course, you can see I've already purchased those here. You're also going to need solder. I'm going to use this 0.6mm solder. And if you have 0.8mm, that should work fine. But the thicker stuff like this 1.6mm, I don't recommend it. It's just too thick for SMD work. Might be fine for the pins, but even for the pins, this thinner stuff really is recommended. Now, it does have flux inside, but I still recommend some external flux. So I have my MG Chemicals No Clean Flux here. Just in case you make mistakes, having a solder wick is nice. This is an older model Hakko, but pretty much any soldering iron will do. Just make sure you have it set to 350 degrees Celsius. You also need a tip cleaner. This happens to be a Hakko 599B, but any tip cleaner will do. And then, of course, I'm going to use the same chisel tip. It's an angled tip that I used in my 4 MB video 4 MB RAM video. And then you're going to need to be able to see well, so having some type of lens on a flexible neck, or just having a lens like this would be great, unless you have perfect eyes, unlike me. And then you're going to need to have a pair of needle nose pliers. And perhaps the most unfortunate part of this entire build isn't the soldering, surprisingly enough. It's that you're going to have to bend every single one of the pins on both of your connectors, both rows, inward, because if you slide your PCB into the connectors, there's too much of a gap there. And so you have to close the gap by manually bending the pins. And we're going to zoom in on that a little bit later, but that's pretty much the setup that you're going to need to do this build. I'm going to start with a 330 ohm resistor first, and I forgot to mention, but it would also be good if you have a pair of very precision style tweezers, because we have some very small parts here, and this makes putting them on the PCB in a precise way much easier. So here we have our teensy tiny resistor, and before I place him on the pads, I want to put a little bit of flux there. I'm using a toothpick because we really don't need that much flux, and if you know, if you put too much, it's not a problem, other than it's difficult to see through some fluxes. And so putting on just the right amount like that is maybe a good idea for us there. Then we can place him on the pads, and this is where your magnifying glass comes in handy, because this guy is small. I mean, seriously small. So, with a little solder on my tip, I'm going to see if I can tack one side of him down. That looks like I got him. Okay. And I applied some fresh solder to the tip. See if I can get the other side. Yeah, I got him. Okay. And next we have the fuse, which is this little guy here with the H on him. Interestingly enough, fuse in Japanese is not pronounced with an F, it's pronounced with an H. Now that's not why the H is on here, of course, but it's just my personal musing. So they don't say fuse, they say fuse. And for those of you who don't know Japanese, it's kind of something interesting. So again, I'm going to apply some flux. Just a dab. It doesn't take a whole lot. But you might even be able to tack him on without flux, because again, there is some flux in the solder itself. But having additional flux always makes things easier, especially for surface mount. And one thing I notice about this guy is that the edges, the very edges of him, just barely come to the edges of the pads. So you really need to use your lens to make sure you plunk him down right smack in the middle of the two pads. Otherwise, he might be too far from one pad for the solder to bridge over to him. All right, so I gotta carefully hold him with my tweezers. Tack him down on one side. That's a good tack. Okay, now we'll approach the other side. That's probably enough, but I'll put a little bit more. There we go. And to make sure my joints are good, I can put my 121 GW multimeter into continuity check mode, and I can see where the traces go. So the top of the fuse goes here. Yep. The bottom one goes to this pad. Yep. And then this leg of the resistor goes to that same pad. Yep. And then the other leg is going to be a bit trickier because he goes to a through hole to the LED side. I got him. Okay, solder is good. And on the flip side of the board, we have the LED pads and the component of sorrow. At least it was for me, because I just spent the last 15 minutes searching for this guy. I pulled him out of the package and it flipped in the air, and sure enough, it fell on the floor. And this is really tiny. I'm really zoomed in on this, and it's hardly any different than crud on your floor, even a clean floor. My goodness. So, you know, folks, I'm not really an SMD guy. I love through-hole because I don't have to worry about these small parts. But whenever you're doing these builds, boy, you have to really be careful. Really be careful. Make sure your work area is definitely clean, because you're inevitably going to have to pop out the flashlight and search for him if he flies through the air. Anyway, we need to make sure that this left side pad is the cathode, or the ground side. And to know that, we see these little green markings here on the left of the LED. And on the right side, there are no green markings. So the green markings means it goes where this little line is to the left of the triangle, which is the leftmost pad. But before we do that, we should apply some flux. We'll place him down very carefully. He is so small, just like the other component we did. He barely even touches the pads. So we really have to focus on making sure he's just centered there. I'm gonna tag him down a little bit too far. That's about right. I'm just at the very edge of this pad, okay. And I put fresh solder on there. And I don't know. I'm not tacking him, I think. I don't see him getting on there. Well, it's so small I can't really see if he's on there. And once again, our trusty 121GW comes to the rescue. In diode mode, I have it set to 3 volts. That will light an LED like this safely. Now I know the left side cathode should go, electrically speaking, to this pad over here. And then I will touch the right side of the LED, just the solder part, with my red probe. And if my soldering job was good, it should light. Oh, and it does! Yay! All right, perfect. Well, now that the easy part is over, oh my goodness, I am not looking forward to this. We've got 2 connectors filled with pins, and we have to bend each and every one of them. My goodness. Oh, I wish this could have been done by machine, but I guess it can't be. You know, I'm one of those perfectionist people. How much do you bend it? And can I bend every one in the same way? Maybe it doesn't matter so long as I bend them all enough, but you know, the left side pins have to be bent to the right, and then the right side pins have to be bent to the left. So, well, I guess I'll just grab, I don't know where to grab, where I should even start. I mean, I read Kay's page, but it's not really that clear. Well, grab, how much of it to bend? I'm not really sure. I guess just haphazardly start bending them, but if I look, it's not really bent. Well, I don't know. I don't know if I'm even being, I don't know if it's even working. Let me take my PCB out here. And, well, it's loosey-goosey, so I see why it needs to go in there that way, but with bent pins. I can understand it. But man, oh man, how to properly bend them? Well, goodness gracious, I almost broke it off, or at least it felt like I did. Scary stuff, folks! I knew even before I started on this project that this would be the most foreboding part. And, well, I'm just going to haphazardly do it. And then in the end, I'll put the PCB in and see if I haphazardly did it right. All right. Well, I bent them so much I can't put them in. I guess that's a good thing, maybe. I can't see either, so I gotta use my lens to have a look. They're not all bent in the same way. I don't want to scratch it up either, right? So, I'm not really sure. I mean, I guess the scratches are inevitable. This is hard, Kay. I mean, I'm not a smart man, so that's why it's not easy for me. How do I get it in there? Now, there's a certain way you're supposed to put it in. There's these little notches, and there's a certain way you're supposed to put it in, but I'm just wanting to do a simple test before I worry about that. And I think I'm supposed to put it not just like this, but to get him in there now that they're bent too much. Well, I'm going to stop the camera and think about it. Found a PCB about the same thickness that I don't really care if it gets scratched up, and so I've been spending the last few minutes running it through all of the pins a few times in hopes of widening them just enough. And but man, it gets kind of scratched up. I mean, this PCB, which I don't care about for this PCB, but you don't want to get your SCSI Rider scratched up. All right, so the notch is supposed to go where it says SCSI Rider. Or you got your LED. It's not supposed to go on the back, you know, where that fuse is and the resistor is. The notch, see your little motorcycle riding Mac? Well, that's the notch side for both connectors. All right, so let's see if I don't know, I might have to scratch him. Maybe he's thicker than my test board. I'm just being careful with him, but I don't want to get him all scratched up, but I don't have any choice. I don't want to take the pads off. Oh, I think I have victory. I think I have victory now. Sorry about the glare. I'm looking at my fingers, not the camera. Well, that seems to have done it with all of the pins making contact that I can see. So you have to check them all with a lens, of course. But okay, well, that seems to have worked. So now Now we have the fun job of bending the other guy. Okay, I'll do that off camera. All right, so here is how the pins are on there. And as you can see, they all are pressed down pretty good on these pads. And maybe that guy right there could be pushed down a little bit more. And there's a couple here that could be pushed down a little bit more, but for the most part, most of them are pushed down pretty good. So just need to adjust some of these so there's no gaps in there, and then make sure the other side is okay. And then you have to make sure that the PCB is perfectly perpendicular to the connector, going straight up and not at an angle. Well, here we are with both connectors on. My idea to use an old circuit board to widen out the bent pins worked quite well. And I did not accidentally bend any pins, but if you do like I'm doing, you just want to make sure that there's no solder clumps or any protrusions along the way. Otherwise, whenever you slide this, slide the connector, right, across your dummy circuit board, then you could accidentally bend a pin. And so just be careful about that. And if you have another way to bend the pins on your end, then go right ahead. Even Keikoba may have a better idea, but that is the idea that worked for me. Now, the critical point before we solder is to make absolutely sure that the connectors are not in any way turned. They have to be perpendicular to your desk when it's in this orientation, in other words. And it's very easy, since none of them are soldered, even though they clamp down, still it's very easy to allow them to bend out of position. And on the back side, this is the flat side of both connectors. Because as I said before, you want to have this protrusion to be visible on both connectors whenever you see the SCSI Rider logo text and the little friendly Mac on a bike logo there. And so that the other side is perfectly flat, my desk is perfectly flat, and then you can just, push down and make sure, push in and push down, and then they're going to be perfectly flat and nothing is going to be at an angle. Because if it's even a little bit off, then your BlueSCSI is going to be mounted a little bit at an angle, and you don't want that. Okay, so rather than put this in my vise, because if I clamp down on it this way, then it could maybe bend the connectors, and I don't want that to happen. So I know it's perfectly straight now, laying on my flat wooden desk, so I'm going to start soldering some pins with it like this, just to make sure the connectors won't move out of position. Okay, I'm going to try it without flux and see how well it solders here. And it solders well enough. It would flow better with flux, but the more flux you use, the messier it is to clean up. And yeah, I'm going to dunk it in alcohol. I do agree, but you need to do that once you're done. But well, if I really need flux on here or not, so it's kind of your choice what to do. But all the while, I just want to make sure it's flat and those connectors are not bent in any way. Well, just for good measure, I said I wasn't going to use my 1.6 millimeter, but let's just see how well that works. It's a lot thicker. Well, it puts a bigger clump on there, which isn't necessarily a bad thing. So I guess, but for the surface mount components, you definitely want to use the thinner stuff. It's more precise to use the thinner, even on these pins. But absolutely for these tiny components, you want to use 0.6 millimeter, 0.8 millimeter, something like that, instead of the really thick stuff. Going back to the thin. Yeah, it doesn't flow as good without flux, but I don't know if that's necessarily needed. Try it with flux. All right. Even with alcohol, you still got to get your toothbrush, and the more flux you put on, the harder it is to clean off. But I'll just see if it's worthwhile. Seeing a massive difference having used it and not. So I would say it's kind of up to you if you want to use flux or just do it dry, because again the solder has flux in it, just not a massive amount. And probably good to do a little bit here, 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 just jump around so you don't excessively heat one particular part too much. I can tell you right now, you definitely don't want to make the mistake with these protrusions. If you put it in the reverse way and you solder it all down, getting this thing off is even with a hot air station, I don't know if you can do it. I wouldn't want to do it. So, on the flip side, because there's those protrusions, it's not stable. See, it bumps around a bit. So I'm just going to tack it down in 3 places on both connectors. It's not anything magical, that's just what I'm going to do. You can do more if you want. I'm just going to give it a good 3. And then stick it in my vise so it doesn't wobble around. That annoys me. Okay, it's in the vise now. And can get up a little bit closer for you. Again, I'm not using any flux. It's just the flux of the solder. So again, if I do use some flux, then just show you how well it goes. Yeah, I guess you could say for that one it did help. But is it a massive difference? Maybe not. Now that I'm finished, I just went through and checked, with my lens, which is basically what you're seeing here, a close-up view of each of the soldering joints, so I can make absolutely sure there's no soldering mistakes, nothing was left without solder on it, and all of the joints that have solder are coated well with the solder. So everything checked out okay to my eyes, and we are done with SCSI Rider 1. So we'll just jump right into the build of SCSI Rider 2. The kit only includes the 4 parts you see here, the PCB, and it includes the fuse, which goes up here, and then it includes the resistor, which goes over here, and the LED, which goes here. And then, of course, we can see 1, 2, 3 connector slots that we're going to have to solder in, but this is a much easier soldering job because we don't have to bend any pins. And here are the 3 connectors you have to buy, and they're linked again on Kay's website, so you can easily do that. But this connector plugs into the Mac's backside out external SCSI. Then this is going to be, it's actually optional if you don't have any plans to, daisy chain. You could just leave this off, but it's kind of a waste if you don't include it. So it's really up to you though. If all you want to do is put a BlueSCSI externally, and you don't care about daisy chaining, then you wouldn't need to connect this. And of course, this is the same type of connector we put on SCSI Rider 1, and that's going to connect to your BlueSCSI version 2. We're going to start with our fuse and apply some flux. Try our best to center him. Okay. Well, it looks like I'm not getting him on there. He's a little bit too big for the pads. Now we'll do a continuity check. The left side goes up here. Yep. So that side's connected. And then this pad here. Yeah. And that's not a problem. Okay, he's soldered on there. And now we have our resistor and LED. And of course we want to put the green side to the left. That's where the negative cathode side is. Okay, I'll check the resistor. I know that the right side pad goes to a through hole over here. And so I'm going to check the resistance across him. And he's connected to the right side of the LED, so I'll just touch the right side. We get 330 ohms. 331 means 330, so he's got 2 good solder connections. And then we will do our LED check with the safe 3 volts. Now the left side pad is ground, so I'll just touch the left side of the resistor, and I know this is ground over here, and if the LED lights, then yay! Alright, so that way I didn't directly touch the solder joints. I just touch the points where they're connected to, and that's how I know my solder joints are good. Now it's time for our 3 connectors. We'll start with the DB25, and on the pin side, you see it's got these little mounting gizmos on the far left and the far right, and these are not really spring-loaded, but they'll help to secure it. And by the way, when you're putting it in here, don't use force, because sometimes, depending on your supplier, the pins could be bent. So you want to make sure. Mine went in nicely, but and it actually kind of locks in there, which is nice. So see, it's not falling out, and it's held in there quite well. So what I'm going to do is just prop him up on the other side a little bit. Since there's no gap between the opposite side PCB and the bottom of this connector, I'm just going to apply some solder on these 2 points. And then I can throw it in my vise and finish it off. And I suppose this is where you could say that thick solder can come in handy. A lot better than the thinner stuff, because there's a huge honking hole here. And just pressing him down, make sure there's no, it's not bent out of position. Okay. And so we'll just fill our honking hole. Honk, honk. Okay. Yeah, there's no air gap. So, yeah. It's on there now, and we can put it in the vise and don't have to worry that it's going to wobble around. And I'm just going to do it without any supplementary flux. And now we're going to put on our other non-optional connector here, a 50 pin, and it's very, very important that you notice the side with a notch. The opposite side is perfectly flat. You can run your finger across it. There's no protrusions. And on this side, there's a bump. You can see it there, right here. And that has to be facing this way. Right, and on the PCB itself, there's a little silk screen marking there, little rectangle, that's helping you. But make absolutely 100%, check it 3 times, you don't want to make a mistake. The protrusion has to be visible. You do not want to install it like this. This side faces that way, right? And this protrusion faces this way. All right. So now, just if it doesn't go in there nicely, it means a pin is bent. So just please keep that in mind. Now, this doesn't lock into place like this connector did. So I'm going to have to flip him over like this. Hold him with 2 fingers. You might have a better way to do it, but I'm going to hold him like this. And then tack him down in a couple places. And that will let me then free my hand so I don't have to keep holding it like this. I'm basically putting solder, excess solder, on my tip because I only have 2 hands, right? Right? I can clean them up later. These are just to tack it down. And you can do however many you feel comfortable with. And they may not look beautiful when you tack it like this, but that's okay. And that's probably enough. more. Then I can, yeah, he doesn't budge. And looking at him from the sides, there's no, I can't detect any gaps, so he's okay, and I can proceed to do the rest. And now we come to the optional connector. If you don't need to daisy chain, then you don't need to buy this. So you can reduce the cost, overall cost of it, because you're going to have to buy all the connectors separately anyway, right? And as you can see here, this is not going to allow you to connect an Apple HD 20SC or some other type of normal hard drive enclosure. This is made for a ribbon cable like this, right? You put a ribbon cable in here to daisy chain another solid state drive such as Mac SD, right? Or any other drive that's SD card, you know, and has a cable. That is the purpose of this last connector. And if all you're planning to do is just buy this and then a BlueSCSI version 2, and you have no reason to daisy chain anything else, then you would just leave this out. And well, the benefit, another benefit is, other than reducing cost, is it's going to make it jut out the back of your Mac less. Not substantially, maybe 6 millimeters you could cut off if you don't install this connector, right? Then it's only going to stick out this much from the back. You know, I'm one of those particular guys about that. Now, some of you will really rail into me and say, oh, yeah, I don't care. I'll just pull out my desk further from the wall, and it doesn't matter if it's a foot long. I don't mind things sticking out. I mind things sticking out. So if I can shave off a few millimeters here and there, that's just my personality. But I realize some of you are different. And so if you couldn't care less about that and you just want to have freedom, well, then go right ahead and buy this connector and solder it in. Because that will give you the liberty of any time you want to put a cable there, you can. Now, I have a BlueSCSI version 2, and of course that's what this is for. And if we just put him in here like this, you know, he'll sit perpendicular to your desk. So this will be the back of the Mac SE30 or Mac SE or something like that, right? And then if you put in your connector here, obviously Kay designed it well, so this is not going to touch, right? There's a gap there. It's not a big gap, but it shouldn't be. Kay intelligently designed this to make sure it's very low profile and doesn't jut out a whole lot. But keep in mind that if you do use this connector, you're going to have sufficient space for the cable behind your Mac too. So. But like I said, for now, I'm just going to leave him off and connect him up like this. And then the last step before testing is to clean off the flux. So I'm just going to put this 100% IPA in here and let that sit for a while, and then take a toothbrush and scrub him. And I didn't use any supplementary flux, so this is just the flux from the solder, and it should be much easier to clean off. And here are our two SCSI Rider units fresh out of their alcohol bath. Now for SCSI Rider 1, you will need a BlueSCSI version 1 that's in the shape like this. You can see the connector here. It's a right angle connector that's firing straight down with respect to the PCB. If you happen to have a BlueSCSI that looks like this, then you cannot use it, quite obviously, because its connector fires straight at you. So please keep that in mind. And by the way, if you're wondering why it says 128 megahertz, you can overclock your BlueSCSI version 1s. And yes, it will give you slightly better performance when you do that, although it depends on the chip that's used. So some of them cannot be overclocked, but that's beyond the scope of this video. And it's a simple matter to just slide him on there, and he snaps right in. And for SCSI Rider version 2, we just take our BlueSCSI version 2 and plunk him right down. Pretty easy. And here we have a Macintosh SE opened up. By the way, I removed the hard drive bracket since I'm going to use the BlueSCSI instead. And the benefit of removing that, as I mentioned earlier in this video, is you can more easily disconnect your main power connector and put him back in, because normally the bracket sticks way out and it's kind of a bother to bump against that and remove it. So it gives you a lot of freedom to have that removed. And even if you have a second floppy drive in here, it doesn't stick out as much as the hard drive bracket. Okay, so make sure that's secured. And then we're going to put in our BlueSCSI to make sure the little protrusions are going to be facing towards the back of the machine. And it's not that difficult at all. Just plunk him right down there. Now, of course, with the case back on, you won't be able to see the LEDs, but I'll just power on and show you how it looks. You can see the little blue LED down here, and of course the BlueSCSI has its own LED lights. And this is the access. When it's booting up, it flashes. And if you're wondering, yes, you can connect SCSI Rider 2 externally with SCSI Rider 1 connected internally. You can have both connected at the same time. It's just you have to make sure that your SD card is set up so that there are no conflicting SCSI IDs. But if you've been a BlueSCSI 1 user, you can actually take your SD card as is and put it in BlueSCSI version 2, and it'll just work. At least it did in my case. So that's kind of neat, something to consider. And here's how it looks from the side. You can see it comes reasonably close to the back of the Mac, but not too close. And there's a pretty good amount of clearance all around. And if you decide to solder in that connector on back for daisy chaining, then it will stick out just a little bit more like this. And when we power on, it's a light show. You've got the SCSI Rider 2 LED over here, and then BlueSCSI version 2 has its own LEDs that will start lighting once it starts booting up here. Yeah, these two extras. And the edge, the right edge here of the BlueSCSI version 2 comes fairly close to the power cable, but not close enough to where you would need to worry. In fact, there's enough clearance to where I can imagine somebody possibly making a 3D printed case for it that might resemble one of those 1990s portable drives that you could attach on the back in the same manner. This Mac SE has a Levco SuperMac 16 megahertz accelerator inside, and it's not super fast, but basically because of the clock speed, it's about double the standard SE, and it's booting off our BlueSCSI here. And I'm not speeding it up. You can see how fast it boots. Right to the desktop. So let's take a look at some benchmarks that I've run. SCSI Director Pro 4 is usually a good piece of software to use. You can download this on Macintosh Garden. See the text description below for a link. And I've already run the benchmarks, so I'm not going to bore you with all of that. So I'll just go ahead and open the files. And I did regular BlueSCSI and, of course, BlueSCSI version 2. So if I open up my regular BlueSCSI, the great thing about this accelerator is I can disable it, so I can run it at the stock 8 megahertz. And this is showing us the stock 8 megahertz, and then I can open up the second one, which is showing us 16 megahertz to show how much of an impact it has on the BlueSCSI results. But basically, it's saying with the 16 megahertz processor, it's maximum read 561 kilobytes per second. With the stock 8 megahertz, it's 523. So 523 versus 561. And you get a modest boost because of the clock speed. And this does have a 68881 math coprocessor in it, but that really doesn't have an influence on this. Also for the 16 megahertz accelerator board, 504 kilobytes per second, and in the stock condition, 429. Okay, so now let's take a look. Now that's BlueSCSI version 1, and all of this is System 7.1. And I also did BlueSCSI version 2. So now we have 8 megahertz, and here is also 8 megahertz, but with BlueSCSI version 2. So even at the 8 megahertz stock speed, this is what all of you stock SE owners can expect for BlueSCSI version 2, maximum read 683 kilobytes per second. And in the stock condition, no acceleration, regular BlueSCSI, that is 523. So it's a pretty big jump, even on a basic Mac SE with BlueSCSI version 2. Also, for the regular BlueSCSI version 1, we get maximum write speeds of 429 kilobytes per second. And with our BlueSCSI version 2, 518. Now I also ran it again with the 16 megahertz clock speed, which is a 68,000, not a 68020 or 68030, mind you. And we get even better performance. Look, maximum reads 728 kilobytes per second, 602 kilobytes per second maximum writes. So if we compare, just based on clock speeds, it jumped from 683 to 728, both BlueSCSI version 2, but just through the CPU clock speed alone, we're getting a pretty big benefit. Now, this video isn't about performance and all that, but I just wanted to show you that SCSI Rider is working fine. I was able to run these benchmarks, and if you're mulling the purchase of a BlueSCSI version 2 beats BlueSCSI version 1, even on a slow SE. And of course, the faster the Mac that you buy, the more performance gain that you get. And I even have some benchmarks here from BlueSCSI version 2, other tests, where I have my Mac Color Classic Mystic running at 50 megahertz. And on that, I'm getting 4,752 kilobytes, almost 5 megabytes per second. Maximum reads and maximum writes, 4,196. So that's extremely fast. BlueSCSI version 2 on but that's a 50 megahertz Color Classic. I even did tests on a Power Mac 9600, and the internal and external SCSI buses are different, so the internal is faster, and I'm getting 8.5 megabytes per second maximum reads, and the maximum write is 6.1 megabytes per second, and that's on the internal with an FWB driver. So if you're running PowerPC, you need to change to a better driver in order to get these speeds. But on a slower Mac, then you would want to go with a different driver. And all of that is discussed by Eric Helgeson on his GitHub, and that can fine-tune performance. All said, the SCSI Rider kits from Kero's Mac Mods are absolutely fabulous, as is BlueSCSI version 2. Now that's not to say BlueSCSI version 1 is bad, but as you can see from the benchmarks, I mean, BlueSCSI version 2, even on a slow 8 MHz 68,000 Mac, they're still meaning to install it. But regardless of which BlueSCSI you may have now or are willing to purchase, there's a SCSI Rider for you for both internal and external use. And by the way, if you happen to have a Mac SD and you want to connect it quickly externally with a ribbon cable, or if you happen to have one of the BlueSCSI internal units like I showed you before, which has the connector pointing in the wrong direction, you can also put a ribbon cable on that. And on Kay's website, he also sells something that's called an OverEasy II This is a version B, and this will allow you to put in the ribbon cable and just plug it into the back of your Mac. So it's just another similar product to SCSI Rider, except this is not exclusive to BlueSCSI. OverEasy II will work with any SD card drive that you attach by ribbon cable to it. So head on over to Kero's Mac Mods website and check out some of the great products he has over there. Keep in mind that he's not the only seller of BlueSCSI, although his SCSI Rider products are exclusive to him. And the OverEasy II by Stephen Arsenault is not exclusive to K, but if you're already buying something from K anyway, you could just add that to your order. I mean, I really use mine quite a lot, so. Anyway, I hope you liked this video. If you did, please consider giving it a thumbs up. I'd love to have your subscription, and please let me know your thoughts down in the comments. Take care and have a wonderful week, folks. Bye-bye.